initially at rest on a rough horizontal surface, is connected to a block B by a light inextensible string that passes over a frictionless pulley. The mass of block A, which is, we have something like this, right? And then we have a block over here, and then we have one hanging here, and they're connected to one another by a frictionless pulley. And okay, so they're saying this is block A, right? The mass of block A, it's X kilogram. So the mass of block A, it's what? It's unknown, right? Okay. While that of block B, it's 12 kilogram, right? When a force of magnitude 124 Newton acting parallel to the surface is applied, as shown in the diagram, block A moves to the left at a constant velocity. So they're saying then there's an applied force going that way, which is F equals to, what is it? 125 newtons, right? What am I missing? Okay, fine. All right. So this is what we have. We have block A, we have block B. This one is lying on the table. This one is hanging this way. So first things first, before we even do anything, let's try drawing. Okay, I'm gonna need, because this is like a tutorial. It's not me exactly teaching and everything. I'm going to firstly, like, I'm going to need you guys to respond as I speak, nah? So what do you guys think are the forces acting on this one, on block A? Like you could just like tell me all the forces acting on block A.
There's FG, there's normal force, tension, I think,
Yes.
and then frictional force, FK.
Yes.
I think that's the only ones I know I can see.
Force applied.
There's what?
FA. Force
FA.
applied.
Yes. FA. So we have our FA here, we have our FK here, we have our tension here, we have our FN here, and we have our FG here, right? That's correct. These are all the, somebody trying to join. No. Okay. So these are all the forces acting on block A, right? Now do block B. What are the forces acting on block B? This is block B, by the way. What are the forces acting on block B? Guys, can you hear me?
Yes, ma'am.
Oh, okay. Yeah, I was saying, what are the forces acting on block? Because this is block A. Now, this is B. What are the forces acting on B? This is the force.
Tension and FG.
Correct. We have tension and FG. Remember, FG does not only depend on the fact that you are lying on a surface. Even when you are hanging, remember, FG, it's just a force that the earth exerts on every object, whether you are hanging from a tree or you're sitting on top of a table. You guys are both experiencing the force of gravity. Do you understand that? So now let's go to 5.1. 5.1, they're saying, state Newton's second law of motion in words. Have I ever sent, what do you call it, examination guideline on the group? Let me check. No, I actually haven't. Sorry about that. I'm going to send you guys the examination guideline. This is where you get your all your definitions, ne? Don't ever just like take your definitions from like thin air and you're like, trying to grasp for what they could mean. Okay, in grade 11, you have to know these examination guidelines. But in the meantime, let's say you know Newton's second law. What is Newton's second law in words?
Acceleration of an object is directly proportional to the net force and inversely proportional to the mass acting on an object.
Sorry, may you repeat that? I didn't hear you.
Acceleration of an object is directly proportional to the net force and inversely proportional to the mass of an object.
That is indeed correct. Yeah, that is actually correct. The acceleration. Okay, but remember I said you have to write it how it is on what? On the examination guideline. If you look at it on the examination guideline, they firstly say when a net force acts on an object, ooh, the object accelerates in the direction. The object accelerates in the direction of the of the direction of the resultant force. And then now here comes what you just said, which is correct. This part over here, the one that I am marking here, this is where your marks are going to come from. You could write this, but if you don't write what I'm going to write right now, what she just said, you're not going to get your marks because these are like your keywords. Ne? So then they say this acceleration is directly proportional to the force and inversely wait, how do I proportional to the mass of the object. Can the person that just said it say it again? Because I feel like if you hear it from her, it'll stick longer. Can you say it again?
Yes, ma'am. The
Mm.
acceleration the acceleration of an object is directly proportional to the net force
Mm-hmm.
and inversely proportional to the mass of the object.
Okay, correct. And see, the acceleration is directly proportional to the force and inversely proportional to the mass of the object. What I'm trying to highlight is that this is a 2 mark question, right? Your marks are going to come from this acceleration is directly proportional to the force and this inversely proportional to the mass of the object. So those are our keywords. You understand? You need to say them exactly as they are. Right. And I mean, this makes sense because this is Newton's second law of motion, MA, right? They're saying the acceleration, which is this, sorry, the acceleration, this, is directly proportional to the force, which is this. So what they mean is that if A increases, F net will also increase, right? And inversely proportional to the mass of the object. Which mass are we talking about? This one, right? So if this mass increases, F net will decrease. Normally, these type of increase or decrease question, we get them in the I think in the multiple choice, right? So now let's go to game 5.2. Where's 5.2? 5.2, 5.2. Oh, I was literally just here now. Okay, 5.2. Let's look at what 5.2 is saying. So they're saying 5.2. So they're saying if the coefficient of kinetic friction, so they're telling us that mu k equals to 0.25, right? Calculate the tension in the string. Remember, if we're given mu k, where do we normally see this? We normally see this in the equation of friction. If maybe we're trying to calculate for friction, we can just go F k equals to mu k multiplied by the normal, right? Are you guys with me? You guys believe this? Like I'm trying to show you what the coefficient, where the coefficient normally goes. That it normally goes here when we're trying to calculate for the friction, right?
Ma'am, what is MK?
It's a coefficient. It's called the coefficient of friction, right? It's just it's a funny. It's not literally MK. It's like I don't know. Yeah. But I discovered in university that it's called mu k. Like that's what they call it, like mu k. But you denote it like this. It's just mu k. And it just means that it's a coefficient. A coefficient is basically a number, like a constant number. In this case, we're given 0.25, right? This 0.25 that we're going to need to multiply the normal force with in order to be able to calculate for friction. So sometimes you're given friction, they ask you to calculate for friction, right? And they give you the mu k. So you should know that it is going to take the form F equals to mu k multiplied by n. This is a standard friction formula calculation for calculations. Sorry. Do you understand now?
Yes, ma'am.
Okay. So if it's kinetic friction, it's just Fk. But if it's static friction, it'll be Fs equals to mu s multiplied by n. Do you get it?
Yes, ma'am.
Do you get this? Okay, cool. So they say calculate the tension in this string. What I need you guys to understand is that if you calculate tension here, automatically it's going to be the tension at this point. Why? Because they told us that this is a frictionless pulley. I don't know, what did they say this pulley was again? Eh. It's a light inextensible. So which means like this pulley doesn't take away any forces from either side. It's just smooth. Even the rope, it's passing by smoothly. Do you understand? So this is A and this is B right here. So you can just, and we're given mu K. Now let's look at our block A because now they want us to calculate this person over here. I mean, it's going to be easy for us because let's redraw this. Let's redraw the free body diagram at A. We have Fn, we have Fg, we have tension, we also have Fk, we also have F applied. We have the magnitude of the force applied. What is it? They gave us to be what? 1, 2, 5. We can calculate the Fg because Fg it's literally just oh no, we're not going to use this one. Sorry, ne? Because remember, we don't know the mass of object A. Sorry, ne? I thought we knew the mass. So we're going to calculate the tension where here at B. Yeah, and it's still going to be the same thing, right? Because we just have B like this. Sorry, I just thought we had the mass, yeah, A. So we're going to have tension over here, and we're going to have Fg over here. These are the only two forces acting on block B. Remember, what is your Fg? How do you calculate for Fg, guys?
It's mass times
It is
gravitational
mass.
force.
Yes, it will be mass times gravity. right? And we know that tension, it's acting in the upward force, and FG, it's acting in the downward force, right, guys? So, okay, uh, wait. So, wait, sorry, ne? So we have F net equals to what? M dot A, right? So for our F net, we know that all the forces acting on the block B, it's what? Let's name the forces. We just have tension, and we have what? We have FG. Ne? So we need to choose one thing as positive and the next thing as negative. So in this case, we'll choose our up as positive and our down as negative. Personally, I prefer it this way, like choosing up as positive all the time, because if you just choose it this way, then it's going to be easy for you, because now you know that uh your gravity, it will be in the downward force. So anything else, it will just be positive, but the gravity will be negative. Am I correct? Am I correct, guys? No, not am I correct. Do you guys understand?
Yes, ma'am.
Okay.
Yep.
Okay. So now we have to state all the forces acting on block B. Eh? Okay, we have tension, which is going to be positive, plus negative Fg, right? Equals to 12 multiplied by. Remember, let's go to what the first statement was saying in this question. The first statement, it said block A initially at rest. So, because if we have something like this, I need you guys to understand this. Né? If we have something like this is block A, right? And then this is block B. And they're connected towards one and to each other by a string. If block A is at rest, block B is also not moving because they're connected to one another. I mean, if block A was moving to that direction, then block B would be like going up, right? Because this one would be pulling it this way and this one would be going up, right? Or let's say if block A was going that way, like if it was sliding towards this end over here, block B would be dropping even more down, right? Right, guys?
Yes,
Like,
ma'am.
do you guys understand what's happening here? Ne? So
Yes,
if they
ma'am.
just say that block A, it's standing still because they're saying initially it was at rest, which means our VI equals to 0 m divided by S, which is meters per second, right? So if they're telling us that the initial velocity is 0, it means block B's initial velocity it's also 0. So which means if its initial velocity is 0, what is happening? There's no acceleration. Acceleration will also be 0 because let's remember, what is acceleration? Can somebody tell me what acceleration is? I get acceleration, it's literally just change in v all over change in time. So if we don't have velocity, which means we won't even have acceleration, right? Do you guys understand me?
Wait, ma'am, you said if there's no velocity, then what?
There's no acceleration. So
Okay.
no velocity, no acceleration. Reason being, acceleration in its definition, like acceleration, it's just the name. But if you were to define it, you would say acceleration, it's the change in velocity divided by the change in time. So if we don't have velocity, it means we don't have acceleration, right? Which is literally what's happening in this question over here. Because they're telling us that block A, it's at rest, which means initially, there is no velocity in the system. And if there's no velocity, there's no acceleration. Do you understand this?
Yes, ma'am.
Does everybody else understand? Like, I can explain, as long as you tell me which part you don't get, I'll explain it. So you guys understand everything here?
Yes, ma'am. Yes, ma'am.
Okay, great. So we have t plus negative fg, right, equals to 12. What is our acceleration going to be? What is the acceleration, guys?
It's 0.
It's 0, correct. So now we're going to have our tension plus, what is Fg? We said Fg, it's m times g, right? What is the mass of B? It's there on the object, on the image. What is the mass of B?
12 kg.
12. So it's going to be 12 times, what is this g denoted as? What does this g?
9.8
Correct.
grams.
Yeah, 9.8, which is equals to 0, because if you multiply 12 and 0, you'll get 0, right? So we have to put a negative here, sorry. Ooh, why did I do it like this? Let me just rewrite it as 12 plus negative 12 times 9.8. You guys all understand why we have to have a negative here, right?
Yes, ma'am.
Okay, great. So now for the tension, we're going to have T equals to, I shouldn't have done it this way. Let me just say negative 12 times 9.8. It's going to give me negative. So we have T, when you multiply these two together, you get minus 117,6 equals to 0. Then in order to get T, we can just transpose this negative 117 to the other side, right? So we're going to have T equals to 117,6. And because tension, remember them, tension, it is a force. So what is its SI unit going to be if tension is a force? What is the SI unit of forces?
Newtons.
Yes, correct. Newton. Then we have our answer there. You guys understand 5.2? Like, are you guys certain that you understand 5.2? Like, you are sure?
Ma'am, can I ask, in place of F net, that's where you say tension plus or minus Fg?
Yes, here,
Oh,
right here. Reason being, these are the two forces acting on this object. Again, we drew our free body diagram and we saw
yes,
that it
ma'am.
has Fg going down and tension going up. So it'll be positive tension plus negative gravity.
Oh,
Yeah. So do we all understand this? Yeah, we're gonna assume everybody understands it. Now let's go to question 1. So we got our tension as what? As 117, what was it? 6 Newton. And remember, I said the system, it looks like this. We have a block B and we have an A over here. This is a light and extensible string. If they say it's a light and extensible, it means that here, over here, right? Over here, this point over here, if it's a pulley, this pulley, it ish, flipping now. It how can I explain this? It allows this string to pass by very smoothly that it does not affect the tension force, meaning that the tension force at this point, it's the same as the tension force at this point. Do you understand? So if we got the tension here, it means that we also got the tension here. Do you guys get it?
Yes, ma'am.
Okay. So in terms of okay. Okay. So now um in terms of where is it? In terms of yes, you, we now know that this is 117,6 because we just calculated here, and we know fa to be 125, and we know fg to be m times g, right? Now let's see what they're saying to us. Five point, this is 5 point ma 5 point, okay, we're going to 5.2.2. So for 5.2.2, they're saying the magnitude of the kinetic frictional force acting on block A. So remember now, if we're now dealing with block A, which is that one, the one that looks like this and like this and like this, and this is tension, this is Fk, this is normal force, this is Fg, and this is F applied. Remember, you can never ever have friction this side. Why can you never have friction this side, like this side? Hey guys, why can you never have friction like going that way? Why should it be that way? Isn't it um, F applied? Isn't it friction? It's always acting in the opposite direction of the F applied. So if F applied is this side, friction has to be this side. If F applied was this side, then friction would be this side, right?
They can't be on the same side.
They can't be on the same side. Reason being, um, let me say we have a phone over here, right? And let's assume that this is a rough surface, ne? And you are pulling the phone. Which direction are you pulling the phone? You are pulling the phone that way. Friction, in its description, it's called the force that opposes. Friction, it's called the force that opposes motion of an object. So friction, what it does, ne? Friction, it tries to slow you down to eventually have you stop. So if you have F applied going that way, friction has to act in this direction. So friction is always in the opposite direction to the force applied. Because let's say F applied was going that way, and then friction is also going that way. Let's say you have your FK and you have your FA. If they're both acting in this direction, then more forces would be pulling the object A in that direction. But that is not the purpose of friction. Friction, in its natural state, it's trying to make this object stop or slow down. So it will always oppose the motion of FA. So friction always acts in the opposite direction of the applied force. Do you get it?
Yes, ma'am.
Okay, great. So yeah, we have our FK here, FA here, tension. What is this? F normal, the normal force, and then the FG. So they're telling us what? Um, the magnitude of the kinetic frictional, kinetic. Kinetic frictional force acting on block A. So we have, this is block A. So they want us to calculate this, isn't it? How did I say we can calculate the friction here? Let's see if you guys are listening, because I did say it. Wait, this is F.2.5.2.2, ne?
Yes, ma'am.
Okay, so remember we have FK, we have tension, we have F applied, right? So they're telling us calculate the kinetic frictional force. Um, any idea how we could go about it?
We can calculate the forces that are acting horizontal.
We can calculate the forces that are
Acting horizontal on block
correct.
A.
Yeah. So because friction, it's acting along the y-axis. So we have our FA going there, we have our FT, and we have our FK. As you guys can see, these forces are all the forces what? They are moving along the x-axis, right? These ones, our normal force and our FG, they are acting along the what? The y-axis, right? Because this is the vertical, this is the horizontal. So if we calculate our horizontal forces, right, we have to equate them to what? To zero. Remember, they said that initially we are running with that, right? They said initially mm, it was its velocity was zero, right? Initially velocity was initially it was at rest, sorry. Initially it was at rest, and they also said it's moving at constant velocity. Velocity. Both these things just imply, they are telling us, these two things, they're telling us that acceleration equals to zero. Do you get it? So you guys get this? Like if
Yes,
you
ma'am.
see initially at rest or constant velocity, it means zero. Reason for constant velocity would be if they're saying you're moving at constant velocity, it means you're moving at the same velocity, right? It means here you were moving at 5, here you were moving at 5. Remember what acceleration is. We said acceleration equals to the change in v all over the change in time. Change in time, it's vf minus vi. If for vf we have a 5, like in this case, minus, again we have a 5, it's going to be 5 minus 5, which is just 0. So you see that here we will have 0 divided by change in t, which is just 0. So if you see constant velocity, here I was just trying to prove to you guys why we have constant velocity also being acceleration equals to 0, right? So because they said it's moving at constant velocity, we know that the acceleration will always be 0. So now we take our horizontal forces, right? Forces acting in the x direction, x axis, or not x direction, x axis, right? So we're going to have, we need to choose one direction as the positive and the other one as the negative, right? In this case, I'm going to take right as positive and then left as negative, right? So we're going to have F net equals to MA. Then tell me in the second step, how are we going to substitute these forces? Please tell me, guys. What?
statement of
Yes, you were saying? Guys, remember,
on the
ne?
statement they say about if block A moves to the left,
They were saying what? On the statement, they're saying what?
block A moves to the left,
Wait, let me go to the question. Okay, they're saying block A initially addressed on a rough horizontal surface is connected to a. Yeah, but look at what they say at the end. They say block A moves to the left at a constant velocity. Remember, I said here our keyword is going to be constant velocity. Even if you are moving, you can move at a constant velocity. And if you move at a constant velocity, our acceleration is going to be zero. That's why I've been trying to emphasize the definition of acceleration. Acceleration is change in v all over change in t. Now let me make a practical example. Ne? This is a car. It's just how do you draw a car? Yeah, let's assume this is a car. This is the this is a car and this is point A. This car at this point, it's moving at 60 kilometers per hour. This is point C. Right? At point C, it's moving at 60 kilometers per hour. And then the car again at point A, it's moving at 60 kilometers per hour. So do you see how speed or the velocity, because speed and velocity are similar. See how this velocity slash speed hasn't changed in between the two points. So when you were moving at C, you were moving at 60. When you're moving at A, you're moving at 60. Do you get that?
Yes,
Right.
ma'am.
So you see, the velocity is not changing. And since well the velocity, somebody wait, let me see. Okay, and since well the velocity is not changing, it means if you have acceleration, which is your change in v divided by the change in t, what is the change in v? The change in v is going to be vf minus vi, right? What is your vf? 60. What is your vi? 60. So you're going to have 0 because this is 60 minus 60. It's giving you a 0, right? So your A, it will eventually be 0 divided by, maybe let's say you took 5 minutes. Yeah, whatever. 5 minutes or 5 seconds, right? Rather. So your A will be 0. So even if you have a constant velocity, you can move. Yes, we can see that that car is moving, but the car is not accelerating, because acceleration is all about the changes in speed. So it means that this block that was moving, which is block A, it was indeed moving, but it was not accelerating. So fact that they told us that it's moving at a constant velocity, we should know that the acceleration will be 0, right? Do you guys get that?
Yes, ma'am.
Okay. So now, no. Sinovuyo, do you get this? I think you were the one that was asking me, or was it? I don't know. I guess who unmuted themselves.
statement
Who? Okay, great. So we will have F net equals to M dot A, where F net will be equals to 0, right? Now, I was saying, show me how you would substitute all the forces acting in the y-axis. Remember, we took right as positive and left as negative. So tell me how you would substitute them here. How would you guys substitute them? All right. Remember, in the horizontal forces, we have three forces. We have tension, we have F applied, and we have FK. So please tell me, how would we substitute them? Right this way, it's positive. That way, it's negative. How are we going to substitute here?
F, F applies,
Okay.
then F applies plus open the bracket, then minus T minus no FK equal to 0.
Minus the t as well.
Yes, ma'am.
Okay. This is actually correct. Ne? But remember, with our question, we decided to take right as positive. So if right is positive and left, because this is right, right? This is our RHS, this is our LHS. If we took right as positive, it means that left will be negative, right? So which means the tension is going to the right. Can you see that the tension, where is it moving? It's moving that way. It's going to the right, right? And FK, it's also going to the right, right? So an F applied, it's the only one that's on the opposite side going to the left. So instead of having them like this, we're going to say positive tension plus FK minus F applied equals to
Mm,
0. This only applies if you
yes,
took your left as positive, ne? Right?
yes, ma'am.
Okay, so sharp. So in the previous question, we calculated our tension. So what can we do now? We can just substitute. Wait, what did they say they want here? FK, ne? So we can just substitute. What is our tension? 117. Here it is, right? So it's 117,6 plus FK minus, what is our force applied, Kana? 125, ne? 125 equals to 0. These things, they're like tens, right? They're both constants. So we can just say 117 minus 125. Yeah, yeah, yeah. 117, comma 6 minus 125, which is going to give us negative 7, comma 4. So we will have FK, FK minus negative 7, comma 4 equals to 0, right? So therefore, if we make our FK the subject of the formula, because that is indeed what we're looking for, we'll just say FK equals to 7, comma 5. What is the SI unit of friction? Guys, guys,
It's newtons.
Yes,
correct. It'll be Newton. Because friction is a force. Tension, it's a force. Friction, it's a force. Gravity, it's a force. Normal force, it's a force. They all have the SI unit, Newton, right? And then, yeah, do you guys understand this? Like the fact that you had to take your horizontal things, your horizontal forces acting in the x-axis. Do you guys understand that? In order to be able to get this,
Ma'am, do you only do from the x-axis?
yes. Cause
Mm.
let's look at something. Ne? They said we should calculate what friction, right? We have Fn, Fg, Fa, tension. And what is this gonna? F. Okay. They told us specifically, they told us calculate friction. And then this friction that they're telling us to calculate, in which axis does it belong to? It belongs to the x-axis, right? Because it's acting along the x-axis. yone friction eo. So which means friction and its friends, applied force and the tension, they are the only forces acting along the x-axis. Hence, we took only the forces in the x-axis. Ne? But hypothetically speaking, had they said to us, calculate your Fn, we would just take the forces acting along the y-axis. But in this case, they spoke about friction, which is on the x-axis. So we only chose the horizontal components. But it's not that every time they're just going to ask us about the ones in the horizontal components. No, they might ask us to calculate Fn, which is in the vertical axis. What hello hi. So it can really go either way. They can either ask you about the force that's along the y-axis, and then you use your y forces, or one that's along the x-axis, and you use your x forces. Do you get that?
Yes, ma'am.
Okay, great. So everybody gets this, ne? Okay. So now let's go to another question. They're saying calculate x, the mass of block A. You're right, block A. Right. Okay, fine. So now we have X, the mass of guys. When it's what time? When it's 1:30. Please tell me so we can do the questions on the group that Sinovuyo sent. Was it Sinovuyo? Yeah, Sinovuyo sent to the group. Nah? 7. Just indicate to me. So we have, they're saying calculate X, the mass of, hey man, calculate X, mass of block A, right? So we had block A like this, and we didn't know its mass, but we know the F. We did, okay. Number one, let's just debug all the forces acting on A, right? Oh my goodness, I've drawn this like so many times. We have Fn, Fat, Fg. Okay, so they're saying we should calculate the mass, right? So we have Fg. What is Fg in its terms? It's m dot g, right? And then we also have Fn, which is the normal force. And then we also have tension, and we also have Fk. We can use Fk to calculate what the mass will be. Reason being why we can use Fk is because, does anybody know what the wait? Okay, okay. So Fk, because we said, remember I said how, okay, we're given the mu k. Fk is the frictional kinetic force. How do we calculate the frictional kinetic force if we're given the mu k? Please tell me, because I told you in the first page. What would it be now? Guys, you can even guess at this point. Guys, remember, this is the only place whereby you're allowed to do mistakes. Here, you do mistakes, they're okay. In class, you're not allowed to do. Okay, well, in class maybe, but on a test, you're not. So rather you speak now, and I rectify you. And what I've learned is that, because I'm also a student, right? The more wrong I become, the more correct I become, because I yeah, if I answer and it's incorrect, I will definitely remember all the time that somebody once said that this is correct, this is incorrect. So I know for a fact I'm not supposed to do it like this. So if you have a thought, just tell it to me, whether you think it's right or it's wrong. Just say it, and I will correct you. I will be the judge of whether that is right or wrong. Don't conclude on your own. Don't disqualify yourself when at Larry you think you're wrong. You don't even know. So what do you think FK will be? Because I definitely did give you this formula in the beginning of the class. When we were talking about the coefficients, remember we said mu k, and then I was like, yeah, this is the coefficient, and then you need to multiply it with something in order to be able to get our FK. So what are we multiplying it with?
Wait, ma'am.
Normal force.
The FK there, would it be UK? UK something. The
Mu k.
coefficient.
No, it's this one. It's FK. I heard somebody saying normal force. That's correct. It's FK, which means frictional. It means I don't know. It means kinetic. This K, it's for kinetic frictional force. All right, which is our FK equals to mu K, which is the coefficient of the kinetic frictional force. Mu K multiplied by normal force. Ish, this is an N. This is an N, right? So this is the formula for friction, for kinetic friction, when you're given the mu K. You guys get this?
Yes, ma'am.
Okay. But it doesn't end here, right? We go, wait, let me write it properly. Fk equals to mu K, which is the coefficient of the Fk, frictional kinetic force, equals to the mu K, which is the coefficient of the frictional with coefficient of the kinetic frictional force multiplied by the normal force. Guys, how do you calculate the normal force? Because we have we're trying wait wait we know what our friction is. It's 7,4, right? Remember from the previous question. I think it was 5.2.2. So when we substitute in, we will have set 7,4 equals to, then they gave us the mu k. Sorry, what was the mu k? Can somebody read from the question? What was our mu k? What was the coefficient? The mu k, sorry. What was the coefficient of the frictional force from the question, guys?
0,25.
0,25, right? Multiplied by the normal force. Remember, we're trying to calculate for the mass of this thing. What is the formula to calculate the normal force? Hey guys, what is the normal force? The formula for normal force? Okay, let's do this. In A, on A, we have our Fn like this, acting opposite Fg. Okay, so these things, they are they are the same but in the opposite directions. What is the formula to calculate Fg?
Mass times gravity.
What? Mass times gravity. Fine, let's say this was just a line. Remember, I said Fn, it's just the same as Fg, just that in the opposite direction because they're acting. This one, it's, let's say this was your x-axis, right? This one, it's below your x-axis. This one, it's above your x-axis. Or rather, This is in your negative y-axis. This is in your positive y-axis, right? So if you have mg over here, it means that the normal force, it's also going to be m dot g. This is the formula how to calculate the normal force, by the way. If somebody didn't know, just write it down anywhere, somewhere. Normal force equals to the weight, which is equals to m dot g. So this normal force, it's the same. Just so you can remember, just remember that it's acting in the opposite direction as fg, but they are the same. It's just that in the opposite. So I get a fg. When we calculate for fg, we have m dot g. So which means fn, it will be m dot g. Guys, I'm coming. So yeah, coming. Okay, so remember, let's get me here. So we have our normal force over here. So we can break down this normal force, right? So we have 7,4 equals to 0,25 multiplied by the mass times the gravity. So we have 7,4 equals to 0,25 multiplied by the mass is what we're trying to calculate for, right? So we have mass times what is our yeah. What is our G?
9,8.
All right. G will just be 9,8. So we're going to have 7,4 equals to multiply this 0,25 into the brackets, right? So we'll have 0,25 multiplied by m. What is it going to give us? Okay, no, I'm lying. 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 Ugh, sorry. I thought it was a plus. You only multiply into the bracket if it's a plus. Ne? If it's like this, just write it properly. This is why I didn't see it. Right, 9,8 m. So if it's like this, you're going to still multiply into the bracket, but you're going to multiply into the 9,8 m, not just individually, as I was trying to do when I was just doing my big head, nothing crazy. But here you have to. That's what I'm saying. Rewrite it in its standard form, and so that you can multiply in properly, right? So now you're going to have 7,4 equals to 0,25, or was it 24? 0,25 multiplied by 9,8, which is giving me 2,48, no, 2,45, right? 2,45 m. And then if you're trying to make m the subject of the formula, we can divide both sides by 2,45. 2,45. Divide. Therefore, our m will be equals to 7,4 divided by 2,45, which is 3,02. As a unit of mass, it's always kilograms. You guys understand that? Do you guys understand this? Like all of it? Like okay, let me try and explain again from here. We were given the coefficient. So once you're given a coefficient, you know that you have to use the fk equals to mu k formula, right? Multiplied by n. And we said that the n, when you break down n, it's just, so I think here the trick was knowing to use this formula and to know that you should break down the n, that n equals to m dot g. This is the formula for the fn. Sorry. Fn, and then you substitute it here. I think from once you are here, you're correct, and you get your full marks. Yeah, because they mark the formula. Yeah, and then the answer, and then the substitution. It's always formula, answer, substitution. Formula, answer. So they would substitute you. So they would mark this as well. So then you get your full 3 marks. You guys get it?
Ish, ma'am, I don't really understand.
You don't really understand. Okay, let's go back to it. Which part? Like where exactly?
The second part. No, sorry, the third one, the third part.
1, 2. This one.
Like from the second part, and then, yeah.
From here. From here.
Yes, ma'am.
Okay, let me just explain from here. Né?
Yes, ma'am.
Actually, let me just explain from here. So we are told that we should calculate the what? The mass of the object. Né? Okay. Reason why we're using this formula is because let's think of everything that has mass that's acting on this object, right? Where we can calculate mass from. We have Fn, we have Fg. I'm only going to name the ones where we can calculate mass. The other ones, I'm not going to write them here. And then we have, sorry, Fk, right? So if we have our normal, we said the formula for normal force, Fn equals to m dot g. This one is standard, m dot g. This is the formula to calculate the normal force. Ne?
Yes, ma'am.
Okay, and then we also have Fg, which is what? F Fg equals to m dot g, right? And then we have Fk. Fk equals to mu naught, which is our coefficient, multiplied by the normal force. Right. Now, from here, you have to choose one formula from the three to calculate for your mass. You might be asking yourself, why did we choose FK? Reason why we chose FK is because here we know more things than here. Because here we don't know what FN is. Here we would need to know this. We already know this. This is 9,8. But we would need to know this so that we can calculate for this. And we don't know this, we don't know this. So already it disqualifies this equation, right? Coming to Fg, we know the G, but we don't know the Fg. We don't know the force of gravity. We know the constant, we don't know this. So if we don't know this, and we also don't know this, it means we have two unknowns, which makes it difficult to calculate for mass, right? And then when coming to Fk, we calculated our kinetic friction to be 117. I think it was comma 6, if I'm not mistaken, Newton, right? So we know Fk, we know mu k. This was given to us in the question as 0 cover, 0 comma 25, right? This is the coefficient. This is the coefficient. And then we have the normal force. What did I say was the equation to calculate the normal force? M dot G. M dot G, right? So if we write this properly, we will have Fk equals to mu k multiplied by the normal, right? So which means it's Fk equals to the mu k multiplied by, what is this kind of? M dot G, because this is the normal, right? This is just the normal force. And remember, here I specified that the formula for normal force, it's M dot G. So then instead of writing it as N, we write it as M dot G. We have our Fk, which is 117, 6 equals to, we have our mu k, which is 0,25. We have our M, we have our gravity, which is 9,8. right? So we have 117,6 equals to 0,25 multiplied by 9. When you multiply these two things together, the number should always come in front and like the variable, the alphabet behind, right? So it should be 9,8 m, right? Then from this step, do you understand until here? Do you actually wait? You understand that this is a standard formula and why we chose this one instead of these two.
Yes, ma'am.
Okay, and then you understand that we had to rewrite this n as m dot g because that is how you calculate normal force. And we were trying, besides how you calculate normal force, we were also trying to
Yes, ma'am.
no, sorry, excuse. We had to rewrite it like this because this is how you calculate the normal force, right?
Yes, ma'am.
Okay, then from here you understand that we had to substitute g as 9,8, right?
Yes, ma'am.
Okay, so see now the only unknown that we have is m. And if we have 117,6 equals to, if we are multiplying outside the bracket, right? We can just multiply into the bracket. Do you get this? This it's a step that we borrowed from maths. Do you understand why we have to substitute, where we have to multiply into it, right?
Yes, ma'am.
Okay. So from here, but 2,48. So from here we'll have 2,48 m. Now, when we want to make m the subject of the formula, we'll divide everything because this is not m, this is 2,48 m, but we want to just remain with 2,48 m, right? So you will divide both sides by what? 2,48, 2,48. This and this will divide. So we'll have our m equals to 117,6 divided by 2,48, which is just yeah, man.
Then
What are you guys
even
getting
one
is
one
your,
seven
it's what?
117.6 is in our tension.
Sorry? Oh, I used the tension.
Yes, ma'am.
Oh, 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 your net's supposed to be 7,4, ne?
Yes, ma'am.
Okay, 7,4, 7,4. So you'll have also here 7,4. So you'll have 7,4 divided by 2,48 equals 2m. What are you getting as m? Therefore, m equals to 3,02 kg. Do you guys understand this? Hey guys, because you had said you didn't get this at first. Do you get it now?
Yes, ma'am.
Okay, you are sure that you understand this formula and you understand the substitution over here.
Yes, ma'am.
Okay, great, thank you. Okay, we're done with this one. Then we're gonna head to the questions on the group. Uh, then after this, guys, I'm gonna send you one question on the group. Please do it, ne? And it's something like this. Please do it so that I can be sure that you get this. Because the next time we meet, I want us to do the universal gravitation, ne? Okay, we're going to start off with. Oh, it's one question actually. Okay, let's look at what they're saying. So they're saying, uh, eh, ngiyabona umndeni kuyo AAU. What the heck? I'm so sorry, guys. Ish, my boss is busy texting. Like, he's been texting me the whole day. How, what guy? Get a grip. What the heck? Do you have pictures showing the whole view? A view of the whole what? Do you have pictures showing the whole venue? A view of what are you even saying? A view of the whole place in one clip, not combination. I'm gonna say no. Um, evening. No, I don't. I'm so sorry, guys. No, I don't. I'm sorry. Should I say I'm sorry? No, say I'm sorry. But let it say it's nonsense. Okay. And I know what's it. Let's go to the group, guys, before this person. Okay. So they're saying on the group, okay, a block, okay, a block M1. Okay, let me draw the system first, then we will do the question. That is 30 degrees, ne? Or 50. Guys, please, Kima, Sinovuyo, please, is that 30 or is that 50?
30 degrees.
30 degrees. Okay, thank you. Um, 30, 8 kilograms, 8 kg, M1, friction is pulley, and then we have M2, 20 Newton. Okay, this is similar to what we've been doing, but the only difference is what? This is at an incline. Do you guys see that? Because it's literally what we've been doing. Just that the other one here the other one it's at an incline. Okay, so let's go to the questions. They're saying a block M with mass 8 kilogram on an incline plane with a rough surface. So this is a rough surface. Take note whenever they say, take note whenever they mention rough surface, we have friction. That could be like a mental note, ne? Ne? Hey guys, don't grow up. You will have bosses that will text you at 7 in the evening. Rough surface, we have frictional. Yeah, we have frictional force. So whenever you hear it is on a rough surface, just know that we have frictional force, ne? Okay. Is the type okay? They're saying the block M1 with a mass 8 kilogram on an inclined plane with a rough surface is attached by light inextensible string to an unknown hanging mass M2. So here we don't know the mass of M2, right? Fine. A force of 20 degree. Hey. A force of 20 Newton is applied, right? We have this is our F net, F applied over here. Um to M1, down from X to Y. Where's Y? So our X is like here and our Y is like here. So they're saying this F applied, because this is our F applied. It pulled down this 8 kilogram from point X to point Y. You guys understand that part, ne? All right. Did you guys understand that? Guys, are we like still together? Goodbye. Guys, I'm muted.
Yes.
Oh, okay. So They're saying this F applied, it pulls down the block from point X to point Y, right? Okay. Um, block M1 is moving down at a constant velocity. Clar, note down, constant velocity. In the previous question, what did I mean constant? What did I say constant velocity means?
Over
Guys,
acceleration.
no acceleration. You are correct. Okay, so if we have constant velocity, no acceleration. Fine. The coefficient of the kinetic friction on the block between point X and Y is 0, 0.2. So they're telling us that coefficient, the coefficient is mu k equals to 0, comma 2, which means we are going to be able to use that fk equals to mu k multiplied by n formula, right? So now let's go to the first question. They're saying draw a free body diagram of block M1, right? So they're saying draw a free body diagram of M1, right? So okay, cool. It's 5 marks, by the way. Let's try to do this. Remember, I don't know if it was you. Yeah, it was definitely you guys. I said, unlike when it's acting on a flat surface, né? When you are supposed to draw a free body diagram of something that's on an incline, start off by making a faint incline that you will be able to erase later on. But wait,
Thing. Then you put it there.
okay. So if you have this like this, you're going to make a dot over here. Remember, you make just a faint incline so that your diagram can be extra accurate. What are Okay, now let's identify all the forces acting on M1. What are the forces acting on M1? Can you guys tell me?
Normal force
We have what?
FG. Normal force.
Yeah, we have the normal force. But remember, our normal, it's acting perpendicular, like at the 90-degree to the surface, right?
Okay.
So, how do you, yeah, the surface. So if you have it on an incline like this, you cannot draw your normal force. You cannot draw your normal force like this because this is not 90 degrees, right? So you are going to be incorrect if you draw your normal force like this on an incline. It only works if it's a surface because this will be 90 degrees on a surface, right? On a flat surface. Sorry, not just any surface, on a flat surface. But since well, this is a incline, your normal will go somewhere like here. Reason you want this angle over here to be 90 degrees. That's what I'm trying to show you guys, ne? Ne, guys?
Yes, ma'am.
Okay. So you have your normal, and then you have your what else? What else do you have?
FG.
You have FG. FG will always act downward, which is your FG. FG on it's going downward, not at the 90, not perpendicular to the surface, but downward. It's just going down. This one is at 90 degree. Okay, what other forces do we have acting on this?
Tension.
We have tension from the rope, right? Because it's attached to a rope on this end. A rope that's also going down to M2. So we do have tension. Tension is going where? That way. So tension. What else do we have?
F applied.
F applied, which is going where? It's going that way. So you have your F applied. What else do we have? Because it's 4 marks, remember? One, two, three. No, it's 5 marks. We only have four down. What else do we have? What are we missing?
Friction.
Frictional force. That's very correct. Then we'll have friction going that way. So, right. So now, can you see you have written all of your forces? So now you go back and you erase this inclined surface. The inclined part, we were just drawing it so that we can have our things being accurate, right? So you erase it. So now you have your free body diagram. Do you guys see it? Now let's go to number B. Number B, what are they saying? Number B, they're saying, number B, they're saying calculate the magnitude. Calculate the magnitude. Calculate magnitude of frictional force acting on M1. Right? So now let's look at where friction is. Friction is along where? It's along your X, your horizontal components. Isn't that correct?
Yeah.
Exactly. So friction is along your horizontal components. So a way in which you can calculate for friction, you can say F net, I get it, equals to M dot A. So okay, let's choose one to be positive and one to be negative. Let's say what is this? This is up. Okay, let's say up as positive. This is down, down as negative, right? This is going up. So if we have up as positive, we will have our tension T plus Fk minus F applied equals to 0. Because remember, they said it's moving at what? At a constant velocity, no acceleration. So 0 over here. So we have our tension. I think they gave us our, yeah, no, we don't have our tension. We have T plus Fk minus 20 equals to 0. So you see, we have two unknowns, but we can fix this because remember, we have a block like this, right? We have tension here and we have tension here. And remember, I said that if you can find the tension, wait, did they give us the mass of block B2 M2? Do we know the
No.
mass of M2?
No.
We do not know the mass of M2. Okay, then we're not going to do it this way. Let me see. Um, FK. Oh, beautiful. We know the mass of, we know, yeah, we know the mass of we know the mass of this, the M1, eh? M1, I think they said it's 8, right? Okay, cool, beautiful. So we have our force F, I think this force diagram looking like, then what are we calculating? Frictional, right? So we have it looking like this, like this, like this, like this, and oh yeah, sorry. And we have our normal, taking our gravitational one going where? Downward like this, right? So remember we said Fk equals to mu k multiplied by what? The normal force. So remember, in the previous question, this one, yeah, this is a beautiful way to show the difference between the questions. In the question, we said our normal force is equals to weight So it is equals to mg, right? Normal force equals to weight equals to mg. But what we really meant was that the normal force equals to the opposite force. And here, what is the opposite force? It's m dot g. I need you to understand that maybe if it's on a flat surface like this, like a table or something, the opposite force of the normal force will be our weight, because they're acting in the opposite of one another, right? But here on this question, we are not going to say n equals to m dot g, because we are going to be what? Incorrect, because they're not opposite to one another. Look at where our fg is, and now look at where our normal is. Because if we say fg will be equals to the normal force, it means we are implying that it would be here, right? Which is incorrect, right? So now we have to find out, how can we find our normal force in this question? Oh my goodness, right? But I need you to understand, this is an incline, and we have fg going downward. So we can resolve our fg into components. You guys get that? So what I mean by that, because we have fg acting at the 90-degree, right? Let's say this is fg. It's acting at 30 degrees. We can get our fg perpendicular. We can get our fg parallel. So you will do this, ne? You will draw a line like this, because we're now breaking down our fg into its components, right? You will get a line like this, which will be our fg perpendicular. Reason why it's our fg perpendicular is because it's at 90 degrees to the surface. Because remember, perpendicular is just things that are 90 degrees to the surface, right? And then for the perpendicular, we will have fg sine theta. And then from this, we'll also have like a x component. This is the y component of the fg. This is the x component of fg. So this is the y component. This is the x component. Do you guys get it? Like, do you guys get what's happening here? Like, we just broke down x into its components. So let's say this was a 90-degree angle. It would look like this. This is, okay, this would be theta. This would be our fg. Fg just got broken down into its fg x component. And this is its fg y component. Do you guys get this and this?
Yes, ma'am.
Okay, beautiful. So now the question would be, this is our Fn, remember. So our Fn, at least now we managed to get what the opposite of Fn will be in this case. So the opposite of Fn will be the y component of Fg. So we can just say, now let's resolve this Fn. So we can say, I'm just going to write for in terms of n in it, n will be equal to
Ma'am,
fg. Yes?
I think I'm not sure if it's only me. Yes.
Oh, no,
Oh,
no,
never
no.
mind.
Yeah.
It's fine
Sorry,
now.
Rene. Sorry. So I was saying, um, so what were you saying yes to when I said, do you guys get this? Or did you guys see it then?
No, I just
Uh,
understood what you were saying. I was writing it down, even though I didn't
oh,
see.
okay. Okay. So we have our y component, right, of the fg, and we have, this is our x component of the fg. So I was saying the normal force now, at least we managed to get something that is opposite to the normal. Because remember here, we said Fn, it is equals to whatever that it is opposite of, right? And in this case, it was opposite to Fg. And we just said Fn equals to m dot g, because we had said that Fn equals to Fg because they're opposite, right? So here we managed to get something that is opposite to our Fn, which is what? The y component of fg. How do you get the y component of fg? By saying fg sine theta. You guys understand why it's FG sine theta and not FG cos theta? Wait, let me just explain it here. Let's say you have a 90 degree. This is theta. This is 90 degrees, right? Let's go SOHCAHTOA. SOHCAHTOA, right? This is theta. Okay. You have SOHCAHTOA over there.
Ma'am, there's someone
Sine.
that's trying to join.
Somebody that's trying to join. It probably kicked them out. Yeah, thank you. So Akira, if we have SOHCAHTOA, what is sine? Sine is what? Opposite over hypotenuse. So a sine is what will be opposite over the hypotenuse, right? So sine is this side. Now let's look at cos. Cos is what? It's adjacent over hypotenuse. So it's this side over hypotenuse. So whenever you're talking y, you're talking sine. Whenever you're talking x, you're talking cos. You get it? So which means that now, in this case, our n will be equals to fg multiplied by sine theta. Because remember I said the perpendicular, it deals with the y. And the parallel, which is this one, it deals with the x component, right? So we will have n equals to fg sine theta. Now let's substitute this n over here. So here we have fk equals to mu k, which is our coefficient. Don't get lost. Multiplied by fg multiplied by sine of theta. Right? So it'll be fk equals to mu k. What is fg? Fg is simply m dot g, which is m multiplied by g multiplied by sine of theta. So our fk will be equals to, we're given the mu k as, what were we given the mu k as, guys? The coefficient. Oh, it's over here, 0.2. So they said the coefficient will be 0.2. What is the mass of the object? The mass, it's 8 multiplied by 9.8 multiplied by sine. You only have one theta in this question. So this theta will be that theta, which is this angle over here. So 30 degrees. So our FK will be equals to then you just put this whole thing into your calculator. So you will have 0.2 times 0.28 times 9.8 times sine of 30, which will be 7.84. 7.84 Newton. Do you guys get this? Sinovuyo, do you understand this?
Yes, ma'am.
Okay.
Hey guys, sorry, nah. It kicked me out. But I was saying, do you guys understand this question over here? Hey guys,
Ma'am, can you take the book down
can you see now?
to the answers at the bottom?
Wait, let me just properly fix it. Mm, painful. Oh, to the answers at the bottom. Is that okay?
Further down, please.
Like down like this or down like this? This is A, this is B. Which
Yeah,
one?
B.
Okay, correct. Yeah, while she's noting them down, Sinovuyo, Tsihu, Lisa, do you guys all understand it?
Yes, ma'am.
Okay, great.
Ma'am, can you show the full answer now? From like FK is close to UK.
FK equals to UK. Whoa. Oh, from here, from this point.
At the bottom right, FG times sine theta.
FG sine theta.
Like
Wait.
N there.
And oh no, this like until here.
Yeah.
Yeah, this is the final answer. This is our FK.
Mm.
It's equals to FK equals to 7,84 Newton. Ne? This is just Newton in this case.